This lesson involves graphing a system of equations. Our answer will be an ordered pair that will make both equations true. We're going to use our skill of graphing an equation in slope-intercept form to find the solution. So for y equals x plus 6, we're going to go to the y-intercept of 6, and we're going to place a point. And then it isn't understood that this is a 1x plus 6, so our slope is just 1, and it will be positive. So we're going to go up 1 and over 1, up 1 and over 1, up 1 and over 1. And we're going to put a number of them going down also. Down 1, over 1, down 1, over 1. It's very important to have a perfect straight line so that you are actually going to see where the two lines intersect. So now I'm drawing the line for the equation of y equals x plus 6. For our equation of y equals negative 2x minus 3, I'm going to, on the y-axis at negative 3, which is right here. And remember, my slope is going to go downhill, so I am going to go up 2, and I'm going to go over 1. That's like a negative 1. And up 2 and over 1. And up 2 and over 1. And there's the point where they intersect. They'll do another one. Up 2, over 1, and again. So now when I am graphing this line, my answer is an ordered pair, and the ordered pair is where x, you can see, is negative 3, and y is actually at a positive 3. So that is those are the values that you would have that would make both of these equations true. And our solution that we found by graphing them is the point where they intersect. This lesson is solving a system of equations using substitution. When you have two equations given to you, you're looking for a value for x and y that will make both equations true. So for this method today, we're going to solve by substitution. My first equation is 6x plus 7y equals 20. And my second one in the system of equations, these two are tied together, is equal to 2x. So to solve by substitution, you are looking for the variable that has a 1 as a coefficient. So in my second equation, I see that for my y. So when I'm looking at this, I am going to take this second equation where y is equal to 2x, and wherever I see a y in the first equation, I'm going to substitute in 2x so I can solve for x. So let's go ahead, and I'm going to copy the first equation down below so I have it right in front of me. I am underlining my y because I know that's where I'm substituting in my 2x right there. So it is going to be 6x plus 7 on the outside of my parentheses. I'm plugging in my 2x. And remember, when it's written beside each other, that means we're going to multiply. So that is right now where I stand. Of course, now I need to simplify and solve for x. So 6x plus 7 times 2 is 14x is equal to 20. And notice, I am now going to add my x's together, so I end up with 20x is equal to 20. And last step, we know from multiplication, the inverse is division, so x is equal to a 1. And right up here, I like to start my ordered pair for my answer because you will be an ordered pair. For every x, there will be one y value and only one y value for the problems that we'll be working today. So now I'm going to go ahead and I get to decide which original equation, do I want to put my 1 in to go ahead and find the value of y? Well, I think the second one would be easier. So I'm just going to copy y is equal to 2x. I'm going to say y is equal to, and now I'm substituting my 1 in for my x. So y is equal to 2. The ordered pair of 1, 2 will make both of these equations true. So let's go to one that's a little bit more complicated. For the first one, it actually gave us y was equal to 2x. Look at the second problem. As we look at this, we can see we have x plus 3y equals 1, and negative 3x minus 3y equals a negative 15. A lot of negatives. We're going to have to be careful today. But I see that my x up here has a 1 as a coefficient. So I know that my first equation is the equation that I am going to go ahead and write so that I have x is equal to something. So let me recopy that, and I have x plus 3y equals 1. In order to get x by itself, I am going to subtract my 3y, and it doesn't matter whether you put it in front or behind the number. I'm just going to put it behind the number. So I end up with 1 minus 3y. So notice that is my x value. So I'm underlining that x, and I know I am going to substitute in wherever I see an x in this equation up here, I will substitute in 1 minus 3y. All right, so now let's go ahead and let's solve this equation that we have. We have a negative 3x minus 3y equals a negative 15. When I'm recopying it, I always double check to make sure I've copied it right, because if I leave out a subtraction sign or a negative sign, it throws my whole answer off. So now I do know that where I see my x, I am going to put in my 1 minus 3y. So here I have my negative x times the quantity 1 minus 3y minus the 3y that is already there equals negative 15. Remember the distributive property, we're going to multiply both, and I just go ahead, I always think of this is a negative 3, and I attach the sign to the second part. So I think of the 3y as a negative 3y. When I'm doing my multiplication, negative 3 times 1 is negative 3. A negative 3 times a negative 3 is a positive 9, and that is a y, minus 3y equals a negative 15. Again, I just copied everything. Now we're just going to solve the equation like we know how to do. You're an expert by now by solving equations if you're solving a system of equations. So I'm going to put those y's together, and I get a negative 3 plus a 6y equals a negative 15. All right, I'm going to add 3 to each side to get the number on the other side of that equation, and I end up with 6y is equal to a negative 12. Last but not least, we need to divide by 6, so y is equal to a negative 2. Again, I like to go up. I like to write my ordered pair, and I have this time my y is a negative 2. So now I need to find x. I can use either one of the original equations, But the first one seems so much easier to me. So I am going to, again, copy the first equation down. X plus 3y equals 1. We don't have to write the 1 there. It's understood. So now x plus 3, remember y was a -2, is equal to 1. And now I'm going to multiply that out. So x, it's plus 3 times -2, a positive. I think I catch this in the front. So that is a -6 is equal to 1. And finally, the last step, I'm moving my 6 to the other side of the equation. So x is equal to 7. Only ordered pair that would make both of these equations true is the ordered pair where x is 7 and y is a -2. This lesson is solving a system of equations using elimination. You'll see that we have 2 equations here. They're related, which means that there will only be one solution that will make x and y true for the value of the equation for the first one and the second one. So with solving by elimination, I'm going to look at both of the equations and I can see that the y's are a pair of opposites. So I'm really excited about that because I know that when I solve by elimination, I am going to combine the x's, the y's, and the numbers. So with having the y's being a pair of opposites, I can instantly just cross them off. And then I'm going to combine my columns and I'm going to be adding them. So here I have a 3x is equal to 11 plus 19 is 30. And I'm going to divide both sides by 3. And so I get x is equal to 10. Well, when I have a system of equations, my answer is always going to be an ordered pair. So I am going to go ahead and I'm just going to put my 10 in there. So I have half of my answer. Now I get to decide which equation I want to go back into and just substitute the 10. And it's the original equation. So I'm going to write x minus y equals 11. I picked the first one. You could pick the second one. I'm going to put in 10 minus y equals 11. Here's my substituting my x value. And of course, I'm going to subtract 10 from both sides. And I end up with a, yes, you have to bring that subtraction sign down, a negative y equals a 1. Well, remember, we cannot have a negative variable. So when we have a negative variable, we're going to divide both sides by -1. So y is equal to a -1. So our solution for this system of equations that we have here, x would be 10 and y is -1. You could substitute the value in and check to see if those answers are correct. The second problem that we have here now, it is a -4x plus 9y equals 9, and an x minus 3y equals a -6. So again, these two are related, and we know that when I'm solving by elimination, I am going to end up combining the columns. So I need to get a pair of opposites. It can be the x or it could be the y. If I multiply, and that's what we do when we need to end up getting a pair of opposites here, I could multiply this equation by just a 4 and I would get a 4x. And here, remember, this is a -4x. So I am going to choose to do that. I could have gotten rid of the y by multiplying by a 3, but I'm deciding to get rid of the x. So I am going to copy the first equation, 4x plus 9y equals 9. And now I'm going to do the multiplication of every term, including that -6. You can't forget that guy. So it is 4x. 4 times a -3 is a -12y. And I write that as -12y. 4 times a -6 is equal to a -24. So I see now that I'm ready to combine my columns, because when I do, I'm going to go ahead and I am going to be able to eliminate my x's. So a positive 9 minus 12y, and that was a positive 9y minus 12y, is equal to a -3y. And 9 minus 24 is equal to a -15. Well, we know that we have to divide both sides by -3 to get the y by itself. So the y is equal to 5. Again, I'm going to start my answer ordered pair up here, and my y is a 5. So now I get to pick, do I want the first equation or the second? And you always use the original. I think I'm going to go ahead and use the second. It seems easier. So x minus 3y equals a -6. I know that I'm looking for my x, and so I am going to substitute in for my y. The 5 that we found is equal to a -6. We know we have to multiply, and when we multiply, be sure to catch that subtraction sign. So x times x, I'm copying down, and now I'm going to multiply this. It's a -3 times a 5 is a -15, and I'm writing -15 is equal to a -6. Again, I see I need to get my x by itself, so the opposite of -15 is +15. And I'm going to do that to both sides. And this cancels out, and I end up with x is equal to -6 plus 15 is a 9. So our ordered pair that makes this system of equations, each of the equations true on its own, is when x is 9 and y is 5. This lesson is about solving a system of equations that will have no solutions. So you shouldn't panic if you see these different weird situations come up. Here's our first system of equations. Y is equal to 2x plus 5, and y is equal to 2x minus 3. Well, if I'm just looking and I know y equals mx plus b, I know these have the same slope, so they're parallel, so they will not meet. Remember, when we're solving a system of equations, when we graph it, they should intersect with one point. So let's solve by substitution. I'm going to underline this y, and where I see a y in the second equation, I'm going to substitute in 2x plus 5. So I'm going to copy the second equation over again that I will be working with. And now, again, remember, wherever I see my y, I will put in 2x plus 5. So 2x plus 5 is equal to 2x minus 3. Looking at what I have there, I know I'm on the right track to be able to find x because I do not have two variables anymore. So I'm going to go ahead and I'm going to move this 2x to the other side of the equation. But this isn't supposed to happen, but sometimes it does. Notice it cancels out where I wanted it to, but over here, my variable also cancels out. And then I'm just going to bring down my 5 on this side of the equation equals a -3. Does 5 ever equal a -3? The answer is no. So when you get a false equation, like we have up above, it's a false equation, we know the answer is no solution. There is no ordered pair where they will meet. Well, let's look at this second example that we have here. 3x plus 4y equals 9, and a -6x minus 8y equals 10. Well, I think I'm going to solve this by substitution because I can see that if I multiply the top equation by the number 2, all of it, I am going to end up with a -6x, and it's going to disappear. Let's do our multiplication of the first equation, where we have to multiply each one of these terms. 2 times 3x is 6x. 2 times 4y is plus 8y. And 2 times 9 is equal to 18. All right, now I'm just going to copy my second equation right underneath it as is. And remember, when we solve by elimination, which what we're doing, we're going to combine our columns. So -6x minus 6x, oh, I get a 0 there. So that's gone. 8y minus 8y, oh, I get another 0 there. So I'm just not going to write that. That's gone. 18 plus 10 is equal to 28. Does 0 ever equal 28? I hope you're saying the answer is no. So this is, again, a false equation that you have in front of you. And when you have a false equation, you get to say no solution. And the good news is, once you find that there's no solution, you don't have to try to find the other variable. You're actually done with the problem. These are the 2 answers to the 2 problems that we've worked together. For this lesson, we're going to be solving a system of equations that have infinite solutions. That means unlimited answers. So when we're looking at our system of equations here, I'm going to solve this by elimination because I do not see any variable that has a 1 as a coefficient. So when I go ahead and I am solving the equation, I am going to draw my line and I'm going to add my columns. So 12x minus 12x, oh, that's gone. That is a 0. And -3 plus 3y, that's also a 0. It's gone. I could write plus 0, but I don't have to. I have my 0 there. And on the other side of the equation, 6 minus 6 is equal to a 0. So when you get a true equation, which we know that 0 is equal to 0, you have infinite answers, infinite solutions. There's your answer. You're done with that problem. Well, let's look at the next example. I see I have 4x minus y equals 2, and a -2x plus 3y equals a -6. So as I'm looking at that equation, I could solve by substitution, but I think it's going to be really easy to solve by elimination. So because I have a -12 here, if I multiply my 4 by 3, I'll have a positive 12. So I know I can definitely get rid of my x's. So I'm going to choose to multiply the whole equation by 3. So the first equation becomes 12x. 3 times, remember there's a 1 there, a -1 is a -3y, or negative 3y, is equal to 3 times 2 is 6. I'm just copying my second equation down now, so I can put them together, because with elimination, we combined the equations. And again, I'm looking at this and I'm like, wow, 12x minus 12x, my x is gone. A negative 3y plus 3y, my y is gone. Say they both have a 0 there. And when I go ahead and I subtract or my numbers, 6 minus 6, again, I get a 0. So this equation is also true. So our solution, our infinite solutions, there's not just one ordered pair, there's many, many ordered pairs. For this lesson, we are going to be solving a system of equations, and this time they're word problems. So we will read the text twice, mark it, and then write 2 equations that would go with the problem and solve it. Looking at the first problem, we have find the value of 2 numbers if their sum is 12 and their difference is 4. All right, so let's mark our text. So we know that we are looking for 2 numbers. Their sum is 12, but their difference is 4. So let's make x is equal to the first number and y is equal to the second number. So our first equation is the sum is 12, so it would be x plus y is equal to 12. The second equation, it's the difference is 4, so x minus y is equal to 4. When I look at this now, I can solve by elimination or I can solve by substitution. But I'm looking at the problem and I do see a pair of opposites. So I'm going to solve by elimination by getting rid of my y's because they're a pair of opposites. So we have a 1x here and a 1x here. So it's 2x is equal to 16. We're dividing both sides by 2. So x is equal to 8. So that is our first number is 8. So now I'm just going to go back to my very first equation of x plus y equals 12. I'm going to substitute in the 8 that we found plus y is equal to 12. And in order to move the 8 to the other side, I have to subtract. So y is equal to 4. Our 2 numbers that we were talking about, the value of those numbers, for the first number is 8 and the second number is 4. So do they add up to 12? Yes. If you subtract 8 minus 4, is it 4? And the answer is yes. So we know our numbers are correct. Well, let's look at the next word problem. That seems to be very lengthy right here. Mary is selling tickets for a play. The first day she sells 3 senior citizen tickets and 1 child ticket, totaling $38. On the second day, Mary collects $52 by selling 3 senior citizen tickets and 2 children tickets. What is the cost of a child ticket? So let's mark our text. Mary is selling tickets for a play. So they mentioned the first day she sells 3 senior citizen tickets and 1 child ticket. And that totals $38. So that's the first day. So that is going to actually be my first equation. But first we need to define our variables. So S is equal to senior citizen. And C is going to be equal to our child. And both of those are our tickets. Our first equation with what we circled, we have 3S plus 1C is equal to $38. We don't need to write our dollar sign. So let's look at the second day, which that's going to be our second equation. Mary sells, they give us the total first, $52 by selling 3 senior citizen tickets and 2 children tickets. And what is the cost? Again, we're looking for the cost of a child ticket. But let's write our second equation. We have 3 senior citizens. This time we have 2 child tickets, and the total is 52. So as I'm looking at this system of equations, I don't see, and I could solve by substitution, but I think I'm going to solve by elimination. You can do it either way. So for this problem, I am going to go ahead and I'm going to multiply the top by a -1. And when I do that, I will have a -3s and a 3s. So there's my pair of opposites, and I'll be able to find the child ticket immediately. So let's do that multiplication. -1 times 3s is -3s. -1 times a +1 is a -1c is equal to -1. You have to remember this guy, times 38 is -38. Now I'm just going to go ahead and I am going to copy my bottom equation. There's nothing I need to do. And once I do that, I can see, indeed, I do have my pair of opposites. My senior tickets cancel out. So -1 plus 2 is 1C, and -38 plus 52 is actually 14. So I know that 1 child ticket is going to equal $14. If I needed to, I could substitute in that 14 into either of the original equations up here, and I would be able to find my senior citizen ticket. But since they're not asking for that, I'm actually able to stop with finding the cost of 1 child ticket. For this lesson, we will be graphing a system of inequalities. If you look here, remembering from the past, in order to graph a line, you must know this equation of y is equal to mx plus b. In order to graph that line, we follow steps 1 and 2, and then we just draw a line. So first we start with graphing letter B. We then go ahead and from letter B, we count our slope. And now, once we draw our line, we have to go ahead and shade the top or bottom. So underneath the things to remember, all of these steps that we just discussed, this is just an example of shading one inequality, where notice everything below this line are the ordered pairs that would make the equation true. Well, let's go to our system of equations. And I have them done in 2 different colors because it will be easier to see when we're graphing our 2 inequalities. So we have the first one, y is greater than or equal to a -3x plus 3. So remember, when I have a greater than or equal to or a less than or equal to, when I graph the line, if it's a negative slope, it's going to be a solid line. If it's a positive slope, of course, it will go this way. When you have a greater than or a less than, when we graph the line, it will be a broken line, which means the answers that are on that broken line are not part of that solution. All right, so let's start with the first one. Y is greater than or equal to a negative 3x plus 3. I'm going to start by graphing my letter B right there. And again, I know the slope is going to be negative. It's going to go downhill from left to right. So I'm going to go up 3, 1, 2, 3, and over 1. Because remember, every whole number is over 1. And I'm going to go up 3 more, 1, 2, 3, and over 1. And I'll go down 3, 1, 2, 3, over 1, 1, 2, 3, over 1. And now I am drawing, because it has a greater than or equal to a solid line. That means that anything on this line is part of the solution. But now I have to see, do I shade the top half of this line, or do I shade the bottom half of this line? And in order to do that, what I usually do is I pick a ordered pair that's really easy to check, and I'm going to pick my 0, 0. So I'm going to substitute in the values for this inequality. 0 is greater than or equal to a negative 3 times 0 plus 3. Well, 0 is greater than or equal to 3. Is that a true statement? 0 is greater than or equal to 3? The answer, of course, is no. So when you get a no, you can check another point, like I've shown you with our other problems, or you know that you're not shading where that 0, 0. That's false. So for this first inequality, I am going to shade the top part of the line. Okay, now let's go ahead and we're going to go to doing the other one, and the solution is going to be where the two graphs overlap. So we have y is less than or equal to x plus 1. I'm going to where the y-intercept is 1, and I am putting my point. And notice it's a positive 1 as the slope. So I'm going to go up 1 and over 1, and I'm just going to do that. Up 1, over 1, up 1, over 1. I like to have it filling my graph so I can really see where my solutions are. And I'm going to go down 1 and over 1, down 1 and over 1, all the way down the graph so I can make a nice straight line. And again, this is less than or equal to, so I am going to go ahead and I am going to make a solid line connecting my points that I have graphed. So I like to check that 0, 0 that I have right here marked, because if I get a true inequality for that, then guess what? I'm going to shade the bottom half of my purple line. So I am going to substitute in 0, 0 into this inequality, and I get 0 is less than or equal to 1 times 0, we know is going to be 0 plus 1. So is 0 less than or equal to 1? Oh, the answer is yes. That means where my ordered pair is, I now will shade it, and that is the bottom part of the line. And I'm starting up here, and notice I am doing all of my shading. So you will ask, well, what is the solution? The solution for this inequality is all of the double shaded areas. It is also what is on this purple line here. And it is also what is on this green line that we have here. Many solutions. Again, where your two inequalities overlap, that's where all your solutions are. So let's look at the second problem I have here. That has a little bit of a problem because it's not in y equals mx plus b form. So I am going to go ahead and I'm going to copy this inequality down below. 1/2 x minus 3 is greater than or equal to y. And we know we want it y equals mx plus b form. So, I'm just going to write my y over here, and I'm going to write 1/2 x minus 3 there. And notice how this is opening up to your expression here. So I know that I need to flip my sign so that it will indeed match where the top one opened up to. So let's go ahead and let's graph the green one. Y is less than or equal to 1/2 x minus 3. So I'm going to -3 for my y-intercept, and now my slope is a positive slope, so it will be going uphill from left to right, and it's going to be going up 1 over 2. Up 1 over 2. Up 1 over 2. And again, I like to go ahead and do that for a lot of the graphs so I can see where things are overlapping. So down 1 over 2, down 1 over 2, down 1 over 2. And I think that's probably good enough. So let's go ahead and again, go back to your symbol. The symbol is going to be, the line is going to be solid because it has that less than or equal to. Sorry about my lack of my straight line there, but you got the idea. So now I'm going to go ahead and I'm going to get the second inequality in y equals mx plus b form. Well, I'm going to copy it. So it's 2x plus y, let me move this one away, is greater than a 1. Well, I'm going to subtract my 2x. So I get y is greater than a -2x plus 1. Again, this is a negative, so I know that it is going to go downhill. And notice my symbol that I have here. It does not have the line underneath it. So my line that I'm going to be graphing is going to go downhill and it's going to be broken. All right, so now we're going to start at 1 where the y-intercept is. And we're going to go, remember it's always over 1. We are going to go, I'm going to do some on top, some on bottom. Up 2 over 1, I'm checking. Is that going to give me a downhill slide? That looks good. Up 2 over 1, up 2 over 1. Let's go the other direction. Down 2 over 1, down 2 over 1, down 2 over 1. Let's do one more. Okay. So now, and I got to do one more. Down 2 over 1. When I'm drawing my line, remember, it must be broken. Those are our two lines. Now, we didn't check to see which is going to be shaded, the top or the bottom for the first one. So I'm going to, again, pick my ordered pair that I like, which by now you know is 0, 0. So here's my 0, 0 point, and I'm looking at my green line. So it's either going to go on the top or it'll be shaded on the bottom. So when I plug in a 0 here is less than or equal to 1/2 times 0 minus 3. 0 is less than or equal to a -3. Again, that's not true. So when I'm looking at my green line now, do we shade on the top where the 0 is? No, we got a false statement. So we know that we have to shade on the bottom of the green line. And here it is. Okay, well, let's go to our purple line that we have. Note, remember, we're going to check, and I love using that 0, 0. So 0 is greater than a -2 times x plus 1. Is 0 greater than our 1? No. Well, that's false. So for my purple line, I am not going to go ahead and shade on the bottom part where I'm kind of showing you now, because there's where my 0, 0 is, for my purple line, I've got a shade on the top. And when I do that, I can see here's my overlap. All of this is part of the solution. What also is part of the solution are the ordered pairs on this part of the line, the green line. What is not part of the solution are any ordered pair that would be on our dotted line. So again, when you're graphing a system of inequalities, in the end, you are looking for the shaded area of where they overlap. And those are your many solutions to your system of inequalities. If this video was helpful to you today, please add a like, comment, and most importantly, subscribe for more Math with Marcia. See you again soon.